kick us off really quickly, and then we will. Kim, you've got the presentation ready to go? Okay.
Yeah. So just KINZA, we're real excited to see this. We've seen, we're very impressed with not just your work, but the work of all the teams we've seen so far. So we see this as the capping off to a great first ever global space school. And really excited to see what you've got here together for us.
All right, so Kim's gonna share the video. I'm gonna ask that all of you stay on mute and also turn your video off just to ensure the bandwidth stays healthy for our live stream. And then once the video is done, we'll start in on a 15-minute Q&A.
I'm still waiting. You have to make sure you stop your video, please. There we go.
Kim, no sound.
Thank you. Hold on.
Of our mission, the -6. Asteroid, and the next.
Okay, hang on. I'm having problems getting this to switch over. 5 seconds.
Hi, so we are KINZA Incorporated, and we are proposing a mission to mine and explore on an asteroid. And the name of this mission is V-7. So everyone in our team is listed below: Pragya, Harika, Robbie, Tanya, which is me, Madeline, and Yurisil. So first of all, we have our team pack. The names of our team members are bordered along the edge, and the flags from each of our countries are in the center, going towards the asteroid. And of course, we have our mission name, V-7, right in the center. So the main objective of our mission, V-7, is to mine on an asteroid, 16 Psyche, and obtain valuable metals to use as resources, which are mostly in limited supply on Earth. The metals from the asteroid will also give us potential to create things like tools and machines and even habitats off Earth. As well as this, the mining on an asteroid could be revolutionary in benefits of space exploration and everyone on Earth. So to achieve this, we had to consider many points such as the mining process, space laws and budget, the tools that would be best for this process. Yeah. So 16 Psyche is the asteroid that we have decided is best suited for our objective and our goals, as I mentioned earlier. This is an M-type asteroid, so it's mostly made up of nickel and iron, and it's very similar to Earth's core. Scientists believe it's very similar to Earth's core. And 16 Psych is very rich in metals, so it has a lot of potential in terms of resources and profitability.
Hello everyone, I am Pragya from Team KINZA INC, and I'll be talking about the methods of mining, tools and equipments required for mining, and extraction of pure metal, that is nickel. So talking about, first of all, methods of mining, that is surface mining and shaft mining. Surface mining, the metals can be scraped off from the surface by scoop, and the larger one can be actively grabbed by the specific machines. Shaft mining, this requires digging of mines on the surface of asteroid and extracting the minerals through shafting. This process requires precise knowledge about the location of minerals. So, talking about the methods of mining, here is magnetic rakes. The asteroids with high metal content can undertake mining by use of magnet. In this, magnet can be used to attract the small fragments, or as here we have mentioned, loose grains. So to extract them easily by the use of magnet. Well mining, this involves creating a well by mining with the use of machines and drills. So extraction of metals is done by Mond process. The Mond process, sometimes also known as carbonyl process, is created in 1890 to refine and to extract and purify nickel. This process involves carbon monoxide combining with nickel readily and reversibly to form pure nickel and nickel carbonyl. So talking about the steps involving Mond process. So the first step is nickel oxide reacts with syngas at 200 degrees Celsius to give nickel, along with the impurities such as iron and cobalt. The impure nickel reacts with carbon monoxide to form the gas nickel carbonyl and leaving the impurities behind. Third step includes the mixture of nickel carbonyl and syngas to be decomposed at 220 to 250 degrees Celsius, resulting in decomposition back to pure nickel and carbon monoxide. The carbon monoxide, hence evolved, can be used for the process of extraction again. This will reduce the amount of carbon monoxide we'll be using. The applications of Mond process involves the rechargeable batteries. It is used as powder form in rechargeable batteries, and the process has also been used for plating other metals of non-uniform shapes and sizes. Talking about the tools and equipments required for mining, to carry out refining on the surface of asteroid, we need specialized instruments and tools. Docking with an asteroid can be performed by using the Harper-like process, which is explained here. Okay, so next one is in situ mining. Will be economically beneficial as it will reduce the cost of transporting the extracted metals. So mining equipments need to be highly automated, or else human involvement will be required for proper functioning and working. Scientists and researchers believe that their ability to mine will improve if human involvement is also there.
Robotic technology for our mining mission. Two of the robotic systems we are planning on using to assist our astronauts when mining on the asteroid are NASA's AutoGopher drill and RASA mining robots. Having automated and remote-controlled systems will be vital for achieving success on this mission, as it both limits the amount of physical work that our astronauts will be carrying out and increases the efficiency of the mining operations, meaning more quality samples and ultimately more profit. Firstly, throughout our mission, some mining processes and surveying of metals will be conducted with assistance from NASA's AutoGopher drill. The AutoGopher drill uses an electric motor to capture cuttings and rotate the drill head. An advantage of this design, and a key reason why it is important for this mission, is that, unlike conventional drill string systems, the maximum drilling depth is only determined by the length of the tether. This is crucial as it removes the need for multiple drill sections, which significantly increase both the weight and complexity for smaller bores. We also aim to use assistance from RASA mining robots technology. Once these robots have scanned various metals and identified the selected resource using the MISR spectroradiometer designed by JPL, the robots activate and work as a group to collect these metals from the regolith and store them back at the module for our return journey. These excavators have been reviewed and praised for their small weight and size. efficiency, versatility over various terrains and low gravity, and their potential scalability for larger mining operations in the future. All these benefits make this technology an extremely valuable and viable option for a mission to an asteroid, and we aim to utilize this machinery on 16 Psyche a lot.
Hello, ladies and gentlemen. I'm Yaroslav, I'm from Kazakhstan, and I'm from KINZA Incorporated. So let's talk about our spacecraft technology. Our flight will be very dangerous, long term, and we need to offer safety, comfort for our crew of 3 or 4 astronauts. So spacecraft will be equipped with advanced environmental control and life support system. Also, we need to think about material. We will use composite materials and space metal for that. Also, our spacecraft need to be technologically advanced. We will integrate composite materials, high temperature and radiation resistant materials, perfect communication system based on laser and optical system technologies, and also we will integrate a perfect flight avionics for our spacecraft. To make a successful space expedition, we need to plan our budget and create a great business plan, so let's talk about that. Our business plan is based on collaborating with other companies and selling them mined resources. Also, our expedition will be long-term, approximately 1 year transit time in each direction. So all work of the mining stations will be completed in the period.
Hello everyone, I'm Harika from KINZA Incorporated. My role in the company is basically figuring out the number of astronauts we would have in the mission and the human element. So in this mission, we will have 3 astronauts, basically an astrophysicist as a payload scientist to determine and analyzing the statistics data and sending back to the ground station, and also having spacewalk if necessary. Geologists will be the main scientists, as it will help us to determine the geological data and also figuring out that the asteroids are ready for the long-term mining or just short-term mining. The biologist will pretty much help us in studying the inner core of 16 Psyche and comparing it to Earth. Also, in the deep space mission, biologists will help us for maintaining crew's health. Human element. In human element, our company has decided to include the life support system, mental and physical health, food supply, radiation protection, and microgravity, power and communication, which is really necessary, like the necessary things in deep space mission. Life support system. As ISS include this type of system for life support, we need a better and reliable life support system for conducting deep space mission. So we will need a high-tech technology that would actually suck up the CO2 and humidity from the spacecraft and have a better oxygen to breathe in. As NASA is pretty much figuring out that how to make the 74% of water recyclable to 94%, and also making the technology reliable and feasible, which is really doable for our new mission.
So talking about the equipment required to support astronauts, that is the manned mission over the asteroid 16 Psyche. First of all, we need appropriate spacesuits, that is for better mobility in various extravehicular activities. Second, the sleeping capsules, restroom and washrooms, exercising compartments. This is a very much necessary entity we require, because it is used to maintain the health of the astronauts, because we suffer from various aspects such as degrading muscle, degrading bones, and psychological disturbances as well. So the next point is highly efficient communication system, because it may require 1 hour to send information or message back to Earth from such an low Earth orbit asteroid. So now I'll be talking about the environmental control and life support system. That is, first of all, we need oxygen regeneration system, water reclamation system, and the artificial regulation of temperature and pressure is also required. Artificial regulation of temperature requires both of the spacecraft and the spacesuits, and it can be achieved by using multi-layer insulation, which will protect the spacecraft from excessive heat and radiation. Medical aid.
Physical and mental health of astronauts is an important aspect of human element because physical health include the prevention of osteoporosis, which is really astronauts are really vulnerable to deep space mission. Also, the changing of red blood cells, and in mental health, basically includes the psyche evaluations that astronauts have to go through so that they don't have psychological pressure while being on the mission and messing up with it. Also, for the Orion mission, scientists have discovered the resistant band, which will really help us determining how many areas of the body we need to work on and how many hours the exercise is needed.
So for the food resupply plan, it was important to factor in nutrient value and shelf life of at least a few years. Of course, the weight of cargo on board is a major concern for any rocket launch, so bringing years' worth of food on board was not a very good option. Some of the food will travel ahead of the crew in a separate rocket, meaning it'll have to be processed and packaged so it stays fresh until the crew shows up. Astronauts will have thermostabilized food and rehydratable food, but they will need to start growing their own food. So Veggie is a deployable plant growth unit to be set up on the space station to demonstrate the feasibility of a space garden. This would provide fresh produce with optimal nutritional value for astronauts and make it so that they wouldn't have to rely entirely on supply missions from Earth. The experiment facility provides lighting and nutrient supply and is capable of supporting a variety of plant species. In addition to growing vegetables in space, it currently provides the largest volume available for plant growth on the International Space Station. So this would be the best option for food supply for the asteroid mission.
Radiation protection, as astronauts will face 100 to 150 rems of radiation at least during their mission. So how exactly our company is trying to overcome this radiation phase? First, we will have the radiation analyzer, which will tell the astronauts how many radiation has he faced and how many radiation can he face further in this mission, or will he be able to complete the mission or not. And if the radiation analyzers say that the high amount of radiation has been intaken by the astronaut, will actually cover the astronaut and the crew members with the mask and barricading themselves from the mass present on these spacecraft rather than sending them that you can barricade it with this stuff. So here in this picture, it's actually a test run. They are barricaded with these things that are present on board the spacecraft. They haven't sent it because of radiation protection. Also, we'll use the radiation asteroid vest, which is the high technology vest, which will help the astronauts to also overcome the radiation and also the heat temperature because it's made of high density polythene. As the radiation also affects the spacecraft, so we have decided to use the combination of hardened electronics, which actually protects the spacecraft technology from radiation. Microgravity. As staying in microgravity for such a long time is not feasible for astronauts, we should decide something that astronauts can easily stay and come back safely. So our team has decided to have the cardiovascular exercises. Along with cardiovascular exercises and increasing the time of exercises, we have decided to use the LBNP, which is lower body negative pressure device, which actually sucks creates a suction, which makes the blood flow regular that it happens on Earth. Problems while mining. Our company has come up with a list of problems that we could face on the asteroid. It's basically facility, power supply, and power backup system, and also the equipment. For the equipment, we don't need to take a lot of equipments from the Earth and also sending the equipments from the Earth to the asteroid in case any equipment is damaged. We'll use made in space 3D printer for creating the equipment for the spacecraft and for the mining. And as for power supply, we'll use RTG for the power supply radioactive thermal electric generator so that it can easily be generated. As for the maintenance of solar panels, our NASA is still searching for the doable option so that our astronauts, while doing the spacewalk, doesn't get electrocuted. For the power backup system, we have decided to use 4 solar arrays to provide extra energy if needed, and also will help in extending our mission if needed. For the communication for fast and feasible, we have decided to use laser communication, but it's deep space optical communication, which uses photons to transfer the communication from Earth to the asteroid. Safety procedures. We'll use SpaceX in-flight escape system, which will help the astronauts to stay in the capsule and return back safely in case of any damage in the spacecraft. This in-flight technology system can work until the main engine is cut off. The astronauts will also be trained to be in the extreme situation they can be. We will create the scenarios we can think of, the worst scenarios that astronauts can be in that situation, the asteroid, and will make them experience before and make them mentally and physically fit.
Landing on 16 Psyche. NASA has planned a mission to 16 Psyche, launching in 2022 and arriving on the asteroid in 2026. Currently, there have been no missions scanning 16 Psyche, so we have a limited amount of information on specific landing zones on the asteroid. However, we are collaborating with NASA and JPL on this 2022 mission so that we can collect valuable information on potential landing zones. We'd be searching for an area that has easy access to good mining locations and is, of course, large enough to contain our module, vehicles, and storage facilities.
How will space mining be regulated by lawmakers? Currently, there are no laws against mining planetary bodies outside of Earth. Any nation is free to mine any asteroid. There are no laws about ownership of planetary bodies or control over planetary bodies. No nation can own or install control in the form of a monarchy or a dictatorship over an asteroid or any type of celestial body. This is a positive and a negative thing. It opens up the possibility of mining resources to anyone who can fund a spaceflight and prevents companies from being able to stop other companies or nations from also having access to the precious metals and resources. The negative outcome of these laws is that if there's an already established mine on an asteroid that finds a large amount of hidden resources, any other nation or company has the right to go to that asteroid and also mine it. This has a high chance of causing conflict on Earth, whether that be between nations, which could potentially start wars, or between companies. Under our current international laws, any samples or materials brought back from a mission are owned by the company or nation that collected them. This means that despite the lack of ownership of that asteroid, the materials mined on them can be owned. This is similar to how ocean mining works. The oceans are not owned by nations but still can be mined by any nation and claim ownership over resources collected. Regulating space mining will be a difficult task for lawmakers. Making sure that all countries follow laws and don't find loopholes will be an ongoing issue as soon as asteroid mining starts. Maintaining a healthy environment for astronauts. Artificial gravity offers a solution to the adverse effects of zero gravity on the human body. One idea is to implement artificial gravity on asteroids. This involves hollowing out and rotating a celestial body. Astronauts would then live within the asteroid, and the centrifugal force would simulate Earth's gravity. Hollowing out the asteroid will also serve to give the astronauts a safe place to live, away from radiation that they get exposed to in space. Advanced Bosch CO2 technology leads to reduced climate threat and increases brick strength. Humans will need a sufficient energy source to consistently provide warmth near the asteroid to sustain life. It is difficult to think about human life without artificial heat. We'll use a water reclamation system that reclaims and reuses about 95% of water. This is very similar to what is used on the International Space Station, as this trip would not be a short one.
Completed in the period of 2 or 3 months, and also our mining installations will work in autonomous state for a half year or 6 months. And mining size is starting from 100 tons of resources. We also planned budget and profit of our expedition. Program cost will start from 15 to 20 billion US dollars. The cost is due complexity and parameters of the expedition. For example, it is a manned expedition, it has a lot of vehicles, we need to mine resources, and it is long term. All resources from 16 Psyche asteroid cost approximately 400 billion US dollars. We will explore from 3 to 7% of all resources of the 16 Psyche. 3 to 7%, it is about 612 trillion tons to 1 and 4 quadrillion tons of resources, or from 12 quadrillion to 28 quadrillion US dollars. So the mission is very profitable and justifies all 12 quadrillion to 28 quadrillion US dollars. So the mission is very profitable and justifies all costs and preparations. Our mission is very complex and serious, and to successfully complete this mission, to send our space vehicles, our crew, and return back them and resources, we need powerful nuclear, electricity and plasma-based jet propulsion systems. To overcome Earth's gravity, we will use radioisotope generators. In outer space and vacuum, we will use ion propulsion and xenon gas thrusters. And also we will use storable propellant hydraulic engines. So this powerful jet propulsion system will be powered by nuclear and solar energetics.
Why should you choose to invest in KINZA Incorporated's mining mission to Psyche? We firmly believe that this mission is not only very beneficial and profitable for our partners, but extremely important for the advancement of humankind in our journey to understand our universe. Through our mission, we'll be showcasing new methods of mining which aim to reduce waste produced from operations, technology which could be very useful in protecting our own planet in the future. There's also been evidence which suggests we can learn a lot about Earth's core through our mining, which could lead to valuable information on potential ways of utilizing our planet in a more sustainable and effective way in the future. Finally, we aim to become an industry leader in manufacturing and transportation using asteroids as interplanetary resource bases and the new materials discovered from our mining expeditions to aid new ventures. Now we ask, are you willing to invest in the advancement of humankind? With some profit as well? Are you willing to invest in KINZA Incorporated's mission to 16 Psyche? Thank you for your time.
All right, as we're getting set up for the panel, if I can ask KINZA to put their video on. And before I put time on the clock, we'll have 15 minutes, as I said. Francesca, I just want to check to see if you are okay starting us off.
Hi, I'm Debika.
Okay,
Can you
good.
hear me okay?
Yes, I just wanted to confirm. Okay, so y'all, we will have 15 minutes for questioning. I'll give you a 1-minute warning as we approach. And Rob, you're off mute, so why don't you get us started?
Okay. I just wanted to confirm, first of all, there seems to be a little bit of a question here, a little bit of confusion. So it's you're asking for $15 to $20 billion, correct? And you're saying that we will return quadrillions of dollars?
Actually, we said that resources, cost of the resources, but we can bring back very profitable cost. So we should invest this money because if we will develop technologies and bring some good amount of resources, we can earn some income. And also cost is due to complexity of the mission. We wanted to be more realistic and plan budget.
Okay, and I understand that. How much do you think you will profit?
We think actually I didn't do the calculations of the profit, but I did other calculations. But we can be sure about the we can be sure that there will be some income. And
Okay, if you
1
can,
trillion, for example, we can earn 1 trillion US dollars. It is by the predicted result of our calculations.
so I understand that the way you based your profit is on the value of the asteroid itself. But for a sound business plan, I think what Rob is trying to get is that what would be the source of your income? If you don't have a number for us, at least can you describe how you're going to generate income based on that?
Should I answer the question? So basically, we are not actually giving the resources back to Earth. We will have a manufacturing team. We will use that stuff for the future space exploration. So our actually profit depends on how much the manufacturing team and how much NASA will give us in future space exploration, because we will provide metals for future space exploration, making rockets and making stuff in the space.
So
Rob
I was going to say, in that case, did y'all do any calculation of what the value of the ore would be to those customers, to those users, to try to do more of an apples to apples comparison on how much value your part of the enterprise is generating?
Yurisil did some numbers. He said that we would be exploring approximately 3 to 7% of all resources on 16 Psyche, and that the program would start from 15 to 20 billion US dollars. Sorry, I'm just answering some of the questions that you had previously, I think. We estimated that these resources would cost approximately 400 quadrillion US dollars, and 3 to 7% of that is roughly 12 to 27 quadrillion US dollars for those resources. Does that answer your question? Or I didn't personally look into that, but I think Yurisil might have.
I'm satisfied with that.
Okay.
Okay, Alex? Not sure if your microphone is working.
His microphone's off.
Okay, well, Alex figured it out. I have a quick one here. So on your selection of astronauts, it's and there's no right or wrong answer here. It's just interesting. You selected 3 scientists, and typically there's always a spot reserved for like a pilot type. Another figure that always comes to mind when you want to do a long-term mission is a doctor, a surgeon. What's your rationale of picking up 3 scientists and not looking into other type of astronauts?
So, yeah, you can go on.
Oh, okay. Well, I'm sure you guys would all know that the astronauts that we send up today have multiple different. They're very skilled in many different areas. So, of course, these people would be excellent in the scientific fields, but may come from different backgrounds and have expertise in engineering and things like that. But you might be able to explain a bit more on that.
So we just made the qualities that of astronauts have. So the commander and pilot will be the biologist, and the main scientist that is going to work will be the geologist who has a geology background. And as for the payload science and for the trajectories, we will have astrophysicists. Does that answer your question?
It does. So did I miss it in a presentation, or you omit that information in your presentation?
Yeah. Yeah. A few of our slides got missed in the video through the editing process. Some of our things were cut short. Sorry about that. It was
Okay.
I did notice that the biologist was also would do medical, but I can't remember some of the other ones. So at least some of that was in the slides there.
Yeah.
I had a question. You had an interesting comment about seeing if you could rotate the asteroid to, and I think the idea is you want to drill down into the asteroid and then rotate the asteroid so that you could use that centrifugal force to be able to give the astronauts a little bit of gravity. So if you start rotating the asteroid, do you think there'd be any difficulty with some of the material on the outside of the asteroid flying off?
Madeline, that was your point, but I think you go, Madeline.
Oh, sorry, no, that was Pragya's point. But I think the thing with the idea is not that would be our first up thing. That would be something that, because our mission is long term, that is like a longer term idea. So if we had it to have a hole into the asteroid, you would have to mine for a while. So there would be a lot of the resources on the outside of the asteroid we would have already sort of collected. So this is more of a long-term idea, not just we get there, we drill a hole kind of situation.
Okay, very good. Thank you.
I also can add some point. As we said before, we will explore 3 or 7% and asteroid 16 site is pretty rich to include these 3 to 7% in the surface, and also we can also use some shaft mining or create some wells. So we can use 2 processes and not to drill the whole asteroid. This was my amendment or addition. Thank you.
Okay, thank you.
Hey, I have a question. Can you hear me?
Yes, we do. Thank you.
So you're mentioning using veggie for food resupply. Was that the only thing that you were planning on using for a food supply for your astronauts?
So veggie was like something that, because right now it's just been working on the International Space Station, so like because this is 2040 mission, so years ahead, that I think that would be our main source of food supply. But other than that, I said for food resupply, there'd be food sent off to a separate spacecraft like ahead of time, and thermostabilized food, and I think that was it, but the main part was just veggie.
Yeah, we also, as Tanya said, thermostabilized preserved food. We would take that as well, because you need to eat in between when the plants are growing, of course. So a mix of both of them, but the veggie was mainly to supply those critical nutrients to keep our astronauts healthy and keep them functioning properly so they can do as much work as possible.
Okay.
I got one last question, if that's okay.
Yeah.
So on the idea of the veggie, do you have an idea of how much volume of plants that you would have to be able to supply food for these 5 or 6 astronauts?
Unfortunately, I didn't look into that. That's a very good point, though. I didn't look into that, but I think just no. I wanted to look into that.
So
Okay, thank you.
So in ISS, basically, 3 plants are used to provide food to 4 astronauts, basically for 6 months. So if we increase the plants, so it can also increase the months. So we are basically providing kind of like 9 plants to 3 astronauts, which can last for 2 years.
Okay, thank you.
All right, I got a question about the MOND process.
Me too.
Okay. I appreciate you describing it for us, because that's not something that I know a whole lot about. But has it ever been tried in lower gravity?
Though I didn't research about that, is it even tried in lower gravity? But yes, it is somehow being used at some places, but we are not sure if it will work there in microgravity. But yes, we can propose the idea of having it as, yeah, we can use carbon monoxide over the surface of asteroid to like get the pure nickel, and the carbon monoxide again will be evolved, that will be used again, so the less amount will be used. So we are going with that process, as it is used for purifying nickel and moreover this iron.
So to add to that, then from y'all's description of the process, it looks like it uses quite a bit of syngas as a reagent. Did y'all estimate how much syngas you would need to process, that many tons of material, and where you would need to get that syngas from? Is that something that would have to be transported from Earth or another source where hydrocarbons like that are abundant, or how does that feed into your logistics strain?
So I believe I didn't research on that one, that how much syngas will be required, because we are not yet sure about the concentration of the metal which is being found there. We need to look into that. By the time we'll be reaching there, like the timeline of our project is for 2040. So maybe we'll be done with the discovery of how much amount of the metals are present. So according to that, we'll be using the syngas concentration as well.
Okay.
All right, we have about a minute left. Anyone on the panel with another question?
I was just happy that they said that they were going to use a made in space printer. That's all.
But wait, it was such a good idea from your Q&A. It has to be done.
Next time though, don't use a picture of my competition's machine.
Who did that?
And then I've got one final question. Let's go back to rotating the asteroid. How do you plan on rotating the asteroid to get artificial gravity?
That's big.
I would like to answer that one.
Okay.
Okay, so this is like maybe it may sound lame to you, but I think like if we go about having an asteroid drilling in it, like well, if we are going with well mining, and so it will require drilling, and then it will be used to rotate the asteroid for the production of artificial gravity. As the ISS is also being rotated to have a kind of like uh, Earth's gravity feel, so it doesn't feel more like microgravity all the time. So we may use, if we go about using well mining, then it may be used for like turning the asteroid for the production of artificial gravity. But we are not yet sure like if well mining will do better there or not. Will it be beneficial for us at that level or not? I hope I made it clear about it.
Okay.
Okay, that is time for our Q&A. Thank you,
Okay.
Kinza, for your time.
Yeah.
Francisco?
Yeah, I'd like to thank you guys. Did a good presentation. The fund you requested is pretty high, so we'll really need to think hard and see if if we can award you the money. But the board is going to get together and evaluate your proposal, and we'll let you know tomorrow. Thank you again for your hard work, and I guess we'll talk tomorrow.
Thank you, everyone.
All right, thank you for your time. We'll see you at graduation.
Thank you. Goodbye.
Bye.
Okay. Uh-oh. Oh, good. Okay.
Devika, you need to put stop on the live.
Say that again.